This was quite a dramatic slide taken in December 2015 during Storm Desmond, when myself and here in this image my dog, my daughter and my son, we all went out one Saturday morning, and this is our return journey home. Our house is just out of sight there and beyond the far road, out of shot, and we were on our way home, and we couldn't get home. Basically, there was such dramatic flooding across the whole region, and it was a very dramatic, impactful, shocking thing to live through, really, and it was quite a visceral thing that we had to experience, and it led on just really framing some of these discussions or some of these thoughts really for what goes on. So it became very personalised. You're probably thinking, what's all this got to do with phosphorus? Well, the reason it's important for phosphorus is because when things like this happen, there's all that hydrological energy that's going on through the system, and liberating and moving and mobilising. Source, mobilisation, delivery, impact, the transfer continuum, and in the mobilisation phase, when you get all that rainfall, which we had during these big storms, then it releases much more phosphorus into out from the earth and into the water systems. So to the next. Do you remember I talked about the demonstration test catchment a few slides ago? Well, indeed, the team were working at Newby Beck in Moorland in the River Eden demonstration test catchment, and by a sort of miracle, really, the team were able to determine the phosphorus and the nitrogen and the sediment export from Newby Beck during Storm Desmond. And the top slide shows the rainfall and the storm discharge and the runoff, and then the other slides show the nutrients. But looking specifically to the next, that meant here we have the amount of sediment that was lost during the storm, the total phosphorus, total reactive phosphorus, which is a nuanced form of analytically determined phosphorus, and the nitrate, which is a oxidized form of nitrogen. But let's just focus on, this is a percentage of the total normal annual in one storm in one day, okay, during Storm Desmond. And we actually estimated between 12 and 22% of a normal annual came out in one storm. 8 to 12% of total P in one storm, the same for total reactive P, and pretty much the same for nitrate. So wow, just think about that. In one day, in one storm, you're losing really between 8 and 20% of the total nutrients from land, just because of these types of flood, big drama, big powerful events that go on. And there's the evidence for it. Okay, so fortuitously, to follow on, I found myself, well, I was involved in a project with a team which were actually specialising in modelling and understanding what the climate change effects would do for phosphorus transfers. And this research, which was led by my colleague Mary Ockenden, started to explore, if you like, the science behind the observations that were in the previous slide. This idea that so we've got these storms happening, we've got these dramatic events, we've observed higher amounts of phosphorus and nutrients coming through the system, but what's the science? What do the models start to show us? And so we had a project which started to look into the patterns of rainfall runoff. Now, the interesting thing is that firstly, historically, we have shown since the 1960s a 31% increase in winter rainfall, and conversely a 16% decrease in the summer. And taking that as, if you like, the back story, looking ahead to the modelled future, the climate change models work based on the climate colleagues that we were collaborating with also show that pattern continues, with a predicted increase in winter rainfall from between 8 to 17% in the future up to the 2050s, and a summer decrease by a correspondingly small amount. So it's all, the whole message is much more winter rainfall and much less summer, more energy in the winter, but a few very intense summer events. And all this is going to mean some changes to the way in which phosphorus and nutrients leave the land. So going to the next slide. So we got really stuck into this, and we used some modelling combined with the data from the demonstration catchments. So in the top, we've got six cells here on this slide. In the top, so firstly on the left-hand slide, we've got DBM, which is one type of model, and on the right we've got HYPE, which is another type of model. And then we've got three rows. At the top, we've got a model for the Newby Beck Eden, which is the catchment which I showed you and the data from. In the middle, we've got data from the Wensum, the Blackwater, which is the arable catchment in the east of England. And in the bottom, we've got data from the Wiley in the Avon, which is a mixed agricultural catchment in the south of England. And we've got a range of scenarios based upon the base condition, 2050s high, 2080s high for both winter and summer rainfall. So a whole range of scenarios there which we were evaluating with this modelling exercise. And it was really complex and really challenging for the team, but they kind of got through it and were able to make some much needed model predictions. And this paper was, as you can see there, was published in Nature Communications, and it's one of the papers which I put on the recommended reading list for ever. But the outcome was that we show a predicted increase in winter phosphorus loads due to climate change, which were going to increase by up to 30% in the 2050s. Wow, and that is technically greater than the feasible reduction from the mitigation measures estimated in previous studies. Only large-scale agricultural changes of a reduction in phosphorus inputs between 20 to 80% would actually result in a reduction in these loads. And we'll have to ask the question, are we prepared for this? It's very difficult to predict phosphorus transfers from land to catchments. It's very important that we try to do that, but at the same time we have to acknowledge the uncertainties in all this kind of work, which is fine. Uncertainty is fine. It's much better that we have uncertainty and we acknowledge it than we have uncertainty and we ignore it. Okay. And sort of moving towards the end of the story, a much broader paper was published as well by this group. I didn't put it on the reading list. Maybe I should have done. You can check it out for yourselves. Andrew Watson, Tim Lenton and Benjamin Mills, Oxygen Deoxygenation and the Global Phosphorus Cycle and the Possibility of Human-Caused Large-Scale Ocean Anoxia. The point of this publication is, it's kind of the one to end on, is that what this paper is saying is so my paper showed that, so I've told you the story that phosphorus is used, it's used in agriculture, it's very important, it leaks to water, climate change is making it worse, right? And that's the Ockenden work and the model paper I showed you. But then this paper says, well, hang on a minute, let's look at the Earth system and model that for the next few thousand years, not very long, might add, in terms of an Earth system age. And their models are saying there is a possibility, as a result of what we have done, if we don't manage it better, that we could have large-scale ocean anoxia, which could have very serious implications for the biogeochemical stability of the Earth in the short to medium term future, which really points to the importance of phosphorus and how we need to give it due attention. So I have a conclusion slide here, which just run through a few points. Phosphorus feeds us. It's key to our existence on Earth, and it's transformed humanity since the 1940s. Its behaviour in soil is tricky. In the long term, it sticks to soil, and plant acquisition is complex. And can we use organic phosphorus and other forms of phosphorus in soil better? Despite this, it's easily transferred to water and causes pollution. Think of the Green Lake 226 I showed you. And climate change estimates are that this will accelerate as we go forward, and perhaps it's on a long-term and non-sustainable journey towards the sea. Now, so that's the kind of, well, it's a kind of doom and gloom story, really, and we're living right through the middle of this now, you know, and us and you and me and you as future ecologists and earth system managers, environmental scientists and geographers have to take this on board and go and change the world and try and do something about this, because, you know, we've got a few issues that I need. Sorry about the lighting here on my, probably don't want to see my face anyway, that's better. The light's changing outside, the sun's going down, and my sort of background light of my other computer is changing the light on the screen. And I just wanted to finish with this final slide, which is also from the book. And it also reminds us of something I haven't really made much of, and that's the idea about sustainable phosphorus supplies into the future. There are concerns about the long-term potential supplies from rock phosphate mines. It is of debate. There were some concerns raised around 2008, 2009 when the phosphate price change. There was a kind of change in when the stock markets crashed, and there was concerns over the price of phosphorus. But then it focused attention on the supplies of phosphorus, and there's been a lot of reflection about this looking forward. As we go from 2009 to 2012, look at the difference there in what we published on the left and on the right, what we found for the two data sets about the sources of phosphate in the world. And the world is today very, very reliant at the moment on supplies from Morocco. So there's a kind of vulnerability for the world in that we get all our phosphate that we use from perhaps only a very few places, and perhaps one or two. And there's a kind of geopolitical fragility in the supply of phosphate there. To the finishing slide here, sustainable phosphorus. I hope it's been helpful to you. I've talked about what it is, why it's important. I've talked about the complexities of its movement through soil and its mobilisation. I've talked about transfers of phosphorus from soils to waters. That's the idea of source, mobilisation, delivery and impact. And I've raised the issue of an accelerating phosphorus cycle. I've raised the alarm. We have to come together and go towards a solution now. And I've also just dropped in there the little bit of a concern about sustainable phosphorus supplies as well around the world. So many people, these are some of the teams that I've worked with over the recent years that have helped me with my research and this contribution. It's been a pleasure teaching you today. I hope you enjoy the other videos and the reading, and I look forward to seeing you as you go on through your journey through the degree. Thank you very much indeed.